Hello everyone, welcome back. Now we are going to do the second topic for algebra, that is geometric progression. Last video was arithmetic progression. If if you have watched that video, this is going to be very easy because we are going to do the same things like we found the nth term of arithmetic progression. Here we are going to do the nth term for geometric progression, sum of series there, sum of series here, and so on. So make sure you have watched the last video. So now this video is going to be very easy to understand, right? Now, starting with what is geometric progression? I will do comparison from arithmetic progression. So this is going to be easier to understand for you. What is arithmetic progression? Here, every next number is increasing or decreasing by the same quantity. Means if I add 5 to the last number, 5 to the last number, 5 to the last number, this becomes a arithmetic progression series. But if you want a geometric progression series, here instead of adding to the last number, we are multiplying to the last number. Means if I say in a series, every number should to get a number in a geometric this series, multiply 2 in the last term. How? If I multiply 2 in 5, I get 10. If I multiply 2 again, I get 20. If I multiply 2, I get 40. If I multiply 2, I get 80 and so on. I hope this is clear. In arithmetic progression series, you are adding. In geometric progression series, you are multiplying. So next term is found by multiplying previous term by a common ratio. Now, it will be easier for you to understand if you have seen the last video. What is the first term? First term is simply 5, means the starting term of the series. And again, here also it is represented using a symbol known as A. So in our case, the first term is 5. A is 5. Common ratio is represented using R. I am going to use a capital R for the simplicity. So the common ratio is what is getting multiplied. Like in this case, the common ratio is 2, right? In arithmetic progression, we have seen common difference. Here we'll see common ratio. How we can get common ratio? Here, take a bigger any term and divide it by the last term. Now, if I take second term divided by the last term means first term, that is 2, right? And if you pick any two numbers in this GP, in this geometric progression series, to calculate R, I will do 80 by the last term means 40. That is again common ratio is going to be 2, and that is what it makes it a geometric progression series. I hope this is easy to understand. Now moving on. Take now an example. Suppose I say make a series of geometric progression where first term is 1, but a common ratio I will say suppose 1 by 5. What are you going to do? How are you going to write the series? First term is 1, second term is 1 multiplied by 1 by 5. So second term is 1 by 5. Again multiply 1 by 5 to this is 1 by 25. Multiply 1 by 5 to it. You will get 1 by 125. Multiply 1 by 5 to it. You will get 1 by 625 and so on. I hope this is clear. You need to understand what a common ratio is and the GP will be easy to understand. In case of geometric progression, the formula, the arithmetic progression, if you remember, this is what a formula of nth term of a AP looks like. In case of GP, nth term is given by A into R raised to power n minus 1. A multiply R and R has a power of n minus 1. I hope this is clear. We'll see in the next slides, or simply suppose for here also we can see 2, 4, 8, 16 and so on. If I say this is geometric progression series, give me the sixth term of the series. So sixth term of the series will be A, common ratio is 2, sixth term is 6 minus 1. So it will give me 2 into 2 raised to power 5. So that will be 2 raised to power 6. And if you calculate this, 4, 4, 66, 64 is the sixth term of the series. I hope this is clear. Even you can check, fifth term will be 6 into 2, 32. Sixth term will be 64. Right? So to this formula is very important for the exam. An is AR raised to power n minus 1. Moving on, suppose this question is given to you that this is a GP and 1 by series 1 by 64 is the nth term of this GP. Tell me what is n. Now 2, 1, 1 by 2, 1 by 2, 1 by 4. Now if you have done the if you have seen the AP video, this is going to be easy to for you to understand. What you are going to do, A is 2. What is common ratio? Common ratio is second term divided by first term 1 by 2, and nth term of the series is given to us as 1 by 64, which we know is the formula is AR n minus 1, right? So 1 by 64 is A is 2, R is 1 by 2 and n minus 1, right? Now what you can do is you can make it like 1 by 128, 1 by 2 raised to power n minus 1. If you see, 1 by 28 is simply 1 by 2 raised to power 7, 1 by 2 n minus 1, right? Now 1 by 2 raised to power 7 is 1 by 2 raised to power n minus 1. Comparing that, n minus 1 is 7. We'll get value of n as 8, right? Answer. So this is how you can solve such question for the geometric progression. This is very similar to an arithmetic progression series. Now moving on. If you remember, in the last formula or in the last video for arithmetic progression, we had a formula very long, n by 2, 2a plus n minus 1 into d. In case of geometric progression, suppose this series is given to you 2, 4, 8, 16, 32, and they ask you, now give me the sum of first 100 term of this series GP. Is it easy? No. So we need a formula for this. So in case of GP, the sum of n terms is A in bracket say R raised to power n, then minus 1 upon R minus 1. See, I am just writing n minus 1 like this so that there is no confusion, because in an we had power of R n minus 1. Here we have power of R as n. So the formula for sum of n terms of a GP is A R raised to power n minus 1 divided by R minus 1. I hope this is clear. This is sum of n terms of GP. But this another formula, another formula, and this formula you surely need to know. This another formula that give me sum of infinite terms of a GP. First thing, if how can you solve this? Suppose I write 1, 1 by 2, 1 by 4, 1 by 8, 1 by 16, and so on. So on. In such a series, rather than n, you can also calculate the sum of infinite terms. How do we calculate it? The formula of infinite terms of the GP series is A upon 1 minus R. Just note it out in your formula sheet. In an exam, they will ask you what is the infinite term of this GP. Then the formula you are going to use is A upon 1 minus R. But, very important, but this formula can only be used if the common ratio is between 0 and 1, right? Between 0 and 1. Or matter of fact, between minus means it's less than 1. Simply we can say it is less than 1, right? Why? I will show you. In this case, 2, 4, 8, 16, 32. Our common ratio is what? Our common ratio is 4 by 2, 2. And if you see, 2 plus 4 plus 8 plus 16 plus 64 plus and so on, sum of infinite terms in this case is infinite only. Here, if the common ratio is greater than 1, if the common ratio is greater than 1, our sum of infinite terms is going to be infinite only. But if the common ratio is less than 1, like in this case 1 by 2, we can use this formula that a upon 1 minus r. What is a in our example? 1. 1 minus r in our case is 1 by 2. If you do the calculation here, you will get sum of infinite terms of the series as 2. So in this series, sum of infinite terms is 2. Why? Because our common ratio is less than 1. So very important very important thing you have to keep in mind. You can only find sum of infinite term of a GP series only when the common ratio is less than 1, right? The common ratio is less than 1. I hope this is clear. Now, moving on. Now they will give now this formula, this is a question given here. You can pause it. Very simple question. You can pause it, try to solve this, and then come back and see the solution. Now they have asked you a is 3, means first term is 3, common ratio is given to you 2, sum of 5 terms. 5 is a r n minus 1 upon r minus 1. Sum of 5 terms is a is 3, r is 2, n is 5 minus 1 upon 2 minus 1. You can do the calculation here, you will get some value and that is the answer. Now, if they ask you what is infinite terms of this series, you can, since r is not less than 1, means r is greater than 1, sum of infinite terms is going to be infinite only. If it has been that r is less than 1, we should have used the formula of a upon 1 minus r. But this is not the case. So sum of infinite terms in this example is infinite only. I hope this is clear. If this is not clear, just rewind the video and watch the last slide where this you will be able to understand what I am trying to say here. Right? I hope this is clear. Now, moving on. This is an important question. Just make sure you pause this video and try to solve this. Very nice question, and I'm very sure if the examiner wants a difficult question or a smart question, they can put this question in the in the exam. First thing, I made a mistake here. I have written that find the sum of GP. This GP 5, 55, 555, 5555. Is this a GP? How can we see? 55 by 5 I know is 11. But 555 by 55 is not equal to 11. 5555 divided by 555 is not again 11. So first thing, this is not a geometric progression series. So we cannot not directly use the formula for GP. And this is a mistake. They could have simply asked you find the sum of this series and they should not have mentioned the GP. First thing clear? Now, let's say sum is 5 plus 55 plus 555 and so on, n terms, right? Now, in this case, take 5 common, 1 plus 11 plus 111 plus 1111 and so on. I hope this is clear. Now, how you can write 1? Simply write 1 is 1. You can write 10 as 10 minus 1. You can write uh, 10 plus 1. And this is, okay. Oh, my bad. This step, before doing the steps, this another hidden step. What you have to do? You have to multiply it by 9 and divide it by 9. So 5 by 9, 9 plus 99 plus 999 plus 9999 and so on. I hope this is clear. I've just divided it by 9 and multiply 9 to every number. So it will give you 5 by 9. Right? 9. How can you write 9? 10 minus 1. How can you write 99 as 100 minus 1? How can you write 999 as 1000 minus 1? And so on. Now here is 5 by 9. Take all tens, 10 plus 100 plus 1000 and such nth term minus of 1 plus 1 plus 1 n times. These are n, right? What is this? This is a geometric progression series. Now you can use a formula for n terms of a series. You will get some value, and here this will be n into 1, that is n. I hope this is clear. So calculate this part using a geometric progression, some formula and minus of n. So you will get the final answer. Again important, write it in your formula sheet, this question, and make sure you take a look at this before the exam. In this case, you are not only able to solve that if they ask you 5 plus 55 plus 555, you can solve it like if they ask you 6 plus 66 plus 666 and so on, or you can also solve this part 1 plus 11 plus 111. The only trick here is divide by 9 and multiply by 9, right? Now, again a trick question, important question and a trick question. So I will mark it as star. These two are the trick question. You need one extra step and you cannot directly use a formula. So that is why I will say this is a trick question. How? Suppose the third term of geometric progression is 4. You can, if you want, you can pause the video now, try to solve it and come back and see the solution. Say third term of a GP is 4. How can you write a nth term of a series? A r n minus 1, right? If they've given you third term means a r 3 minus 1 means a r square of a series is 4. I know this much, that a r square is 4. Now they have asked you find the product of first 5 terms. It is not the sum but product. What are the first 5 terms? First term is a, second term is ar, third term is ar square, fourth term is ar cube, and fifth term is ar4. If you do the product of these, you will get a5 and r as 1 plus 2 plus 3 r10. I hope this is clear. The product is product of all this a into ar square and so on. You will get a raised to power 5 and r raised to power 10, right? Can you not write it like this, ar square raised to power 5? Simple step. Do you know the value of ar square? Yes, from here the product is 4 raised to power 5 answer. Again, nice question. The third term is given. They have asked you product of first 5 terms and you calculated by doing it first term as ar square and so on. Right? I hope this is clear. Now moving on quickly. In geometric progression series between two numbers, there is one geometric mean. If you have seen the arithmetic progression series, you will be able to find the recall what is the definition of the GP should be, geometric mean should be. A geometric mean is a number which, if is put in between two numbers, make this a GP series, right? If this is a GP series, the common ratio has to be the same. Common ratio here is G by A. Common ratio here is B by G. Since both are equal, G by A is equal to B by G. So you will get G square as AB, and the geometric mean is G is under root AB, right? This is again, I am putting a star here, right? Now, they have asked you, they have given you two numbers A and B. Again, there are, suppose say, there are n geometric means between these two numbers. How are you going to do it? If you know it from the last video, our first term is A, our nth term is B, and the number of terms in this series is n plus 2. This is what we have understood in our arithmetic progression, arithmetic mean. Why there are n plus 2 terms? Why? Because there are n geometric means, plus A is there and plus B is there. Now you can just punch in the number that A n we know is A r raised to power n minus 1, and that is equal to B. This I am putting n. A is A, r, n is n plus 2 minus 1, B. So you will get r is equal to B by A, 1 by n plus 1. You don't have to remember this formula. You just have to know the working of it and you will be able to recall the formula in the exam. Again, we'll do a question here. you can take a pause here and try to solve this. Very similar question to what we have done in the arithmetic mean video. We need 3 and 48 are there, and there are 3 geometric mean between it, G1, G2 and G3. Right? I hope this is clear. Now, what is the first term? 3. What is the number of terms in this? There are 3 geometric mean plus these 2. That is 3 plus 2, 5. What is the last term, nth term? 48. So, you will say an is a r n minus 1. So, a is 3, r is 5, n minus 1 is, yeah, right, n minus 1 is, uh, oh, my bad, this is, sorry for the mistake here. We still don't know what r is, but we know a is 3, r, n is 5 minus 1 is equal to 48. So, if you do the calculation here, a raised to r raised to power 5 minus 1, that is 4, is 48 by 3. So, r raised to power 4 is 16. So, you can see r is 2. I hope this is clear. We got the value of r as 2. So, to calculate what is G1, 3 into 2 is 6 is G1, 6 into 2, 12 is G2, 12 to the 24 is G3, and 48 is the last term. I hope this is clear. Important question, right? Like what we did in the last video, we are going to do a quick recap of the formulas. First formula in the geometric progression series is nth term is a r raised to power n minus 1, and I will write nth term of a arithmetic series just as a quick refresher. Sum of n terms of the series is a r n minus 1 upon r minus 1. But if the sum of infinite terms of the series is a upon 1 minus r, given the ratio has to be less than 1, right? Here the sum of the n term was n by 2, 2a plus n minus 1 into d. I hope this is clear. Now what we did, we saw that geometric mean was under root something ab. Here arithmetic mean, if you see from the last video, was a plus b by 2. Now we did was more than one geometric mean. That is what we have learned from the working, that a and b are given. Put g1, g2, g3 there and solve the question. I hope this is clear. This video is very similar to arithmetic progression. If you just watch the two videos simultaneously, you will be able to differentiate, and make sure you have these formulas in your cheat sheet for sure. And also from our end, I will try that once our algebra part is over, I will make a quick video as a quick refresher of all the formulas and important question what we did in the algebra part, so that you are able to recap what we have done in n number of videos. Right? That's all for this video. Thank you for your time and best of luck.